Let's see. So first approach that we are doing is we are taking a position array of size n, and we are saying, hey, please go ahead and start filling this position array. A and n remain as it is. What we do is we take two extra indices. AI keeps track of position in array A, and pi keeps track of position of index in pos array. I'll say keep track of index in A array. So both we are starting from left to right, right? So I'll pass AI, I'll pass pi, and I'll also pass position array. So these are the parameters that we are passing to this function. This is what we are defining as our state. So let's go back and say this is the function. Call it a helper function that we are writing int n into position array. So before that there is a index, there is a position, and there is a pi index. Right. So I'll call this as helper, and rather than helper I can also call it like this is approach 1. That's much better. It will help us track our functions easily. Right. Now just see what we did in our approach. We said when we are into this function, when we were looking at the first position pi, the choices that we had, we were filling the position pi with those choices. So our first is fill pos of pi with possible choices and go ahead recursively. This is what we decided. So what are the choices for pi? So our choices are start with index ai, go till length of the original array A, and say position of pi is equal to a of I. So if you see, this loop will make sure that this pi position is filled with various possibilities in the array A. After we do that, after current position is filled, ideally we should print subset, and then we should make a recursive call to generate more subsets. So generation wise we say a, n. Now what element from array ai we will select? Currently we have selected ith element, so the next possible choices are I plus 1 onwards. Position array remains as it is. We just now filled position pi. Recursively we would want to fill position pi plus 1, right? So this is what is the transition of state. So from here we make a recursive call to that. Now print subset, we can write a function for that. Print subset. So ideally we give an array, we give the size of the array, and we want to fill print. So I0, I less than n, I plus plus. I'll say printf %d space a of I, and let's give a new line for every subset that we generate. So subset, when we are generating and printing, we'll print a subset. Ideally, if you see pi is the recent index we have filled, that means we want to print pi also. So what I'll do is I'll pass pos, and I'll say pi plus 1 is the size, because size should always be 1 greater than the indices that we want to print. Right? So this way we will go ahead and we will say there were 3 positions, you had 1, 2, 3. What we are doing is for this position we are considering all 3 possibilities. If you see, that is what we are doing. This loop is making sure that we are considering all possibilities, and once we have filled 1 here, we are saying next 2 choices are 2, 3. That's where we are saying if we have selected AI, our next choices start from I plus 1. In the same way, if you fill 2 here, the next choice starts from the next index onwards. That's why this is I plus 1. Now where should we end? Ideally, if you see, if our AI has become equal to n, which is original array gets over, then what we will do is we will say hey return, we don't have anything else to do. So this is kind of our boundary case. Printing anyways we are doing immediately as soon as the subset is built, right? So this is our approach 1 into code. So let's go and try to run it. So I'll compile the program. So program got compiled. I'll run it now. And if you see, when we are running, the subsets that we are generating are, first we filled 1 as a choice, then we filled 1, 2 as a choice, 1, 2, 3. Then we went back, filled 1, 3 because second choice has started recursing because two choices here. Then we go back and replace 1 with 2 and then 3. So if you see, these are all the subsets of 1, 2, 3. Ideally, if I go and print now all the subsets of 1, 2, 3, 4, 5, you will see that the same program that we are running, I'm just compiling and running in the same step. So if you see, same program is printing all the subsets of, oh, sorry, I think I ended up pasting something here. So all the subsets it's printing of this array. Right? So this winds up our approach 1. In next video we will move on to approach 2.